Chapter 10, Section 7, Addition Rule for Probabilities. We're going to compute probabilities using the addition rule for mutually exclusive and non-exclusive events. All right, so two events are considered mutually exclusive if they both cannot occur at the same time, as in there's no outcome in common. So this is the visual of mutually exclusive. This is the visually of not mutually exclusive. There's an overlap between the sets. So A and B are mutually exclusive when we have an event A is rolling a 3 on a die. Event B is rolling a 4 on a die. Clearly, they're totally mutually exclusive events. You can't get a 3 and a 4 on a die. All right, when you select a card from a standard deck, the card is a 4 or an ace is what we're looking for. There's no overlap between being a 4 or an ace. Okay. When A events are not mutually exclusive, that means there's some way you can satisfy both at the same time. So for instance, if event A is a male student and B is a nursing major, you can have a male nursing major in the overlap section. So they're not mutually exclusive. Rolling a number less than 3 or rolling an odd number. Rolling a number less than 3 for A and rolling an odd number for B, well, one clearly fits into both categories, so that's an overlap. So these two events are not mutually exclusive. Okay. Notice they're using the word or in these, or. Okay. When you have an or, we're talking about the addition rule for probability. The probability that events A or B will occur if they're mutually exclusive is the following formula. You're just adding each probability from each event. Okay. If they are not mutually exclusive and there's overlapping outcomes, they must be subtracted back out. Okay. So if you're calculating a probability, you want to take the probability of the event A plus the probability of event B minus the overlap, which would be the AND group. Okay. So for example, for mutually exclusive, rolling a 3 or a 4, right? Just one side of a 6-sided die, one side of a 6-sided die. You add their probabilities together when it's an or. You get a 2/6, which is 1/3. Pick a 4 or an ace. So you take the probability of picking a 4 plus the probability of picking an ace, add them up, and reduce the fraction if you need to. Okay. But if they're not mutually exclusive, rolling a number less than 3 or rolling an odd number. So remember, less than 3 has the outcomes of 1 and 2. Rolling an odd number has the outcomes of 1, 3, and 5. Okay. So a common outcome would be rolling a 1. So there are 2 possibilities out of 6, 3 possibilities out of 6, minus the 1 overlap is going to give you 4 out of 6 or 2/3.